Hello guys, my name is Abhijit. Today's video is about Euler's formula, like Euler's identity, the famous Euler's identity which you learn in a mathematics course. The cos theta plus I times sine theta equal to e raised to I theta, right? So when I was in my 10 plus 2 class, I always had a doubt about this identity. Like here you got the two functions, you're adding them and suddenly you're getting exponential. How is it possible? So when I asked my teacher, he gave me the proof about the principle of mathematical induction, right? Where you put the variable value equal to 1 and check it out whether it holds good or not. Then you assume any random variable like m and you prove that it will hold good for m plus 1 too. So it was like indirect way, to prove about this identity. And since I was in my 12th, I wasn't aware about the derivatives. I was just started with the derivatives things, So I was confused about this identity. And when I asked my professor C.G. Kulkarni, he told me about this proof, The trick is very simple, All three functions like cosine, sine, and the exponential functions can be written in terms of sum of an infinite series, right? So let's check it out, how to do it. So I'm just changing my variable here. Instead of theta, I'm taking x. So this is the Euler's identity. E to the power x is equal to cos x plus I times sine x. So sine x can be written in terms of infinite series like this. Sine x is equal to x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on. The sum of an odd powers, right? Now what about cosine x? If you don't remember, it's okay, because derivative of sine x is cosine x. So just differentiate this, you'll get the corresponding sequence for the cosine x. So differentiation will be like 1 minus derivative of this is 3x squared upon 3 factorial, which is equal to like 3 gone, so it is like x squared by 2 factorial plus x raised to 4 by 4 factorial. So just make it one power less and go on. So here it's the cosine x, 1 minus x squared by 2 factorial and minus x raised to 6 by 6 factorial, right? And just continue. Now let's consider the right hand side of this equation. Yeah. Okay, so what I have done here is right hand side, I consider the right hand side of this equation, cosine x plus I times sine x. So the cosine x can be written from here, that I have put it here in bracket, plus I times the sine x, x minus x cubed by 3 factorial. That's how I written it here. Okay, now let's just open up the bracket and simplify the things. Let's see what we're getting, right? So here we have 1 plus I times x, right, minus x squared by 2 factorial minus I times x cubed by 3 factorial plus x raised to 4 by 4 factorial plus I times x raised to 5 by 5 factorial minus x raised to 6 by 6 factorial and so on. You can go on like this. Now let's do some little bit manipulation, to simplify this. Okay, so 1 plus ix as it is. Now again, minus 1 can be written as I square. Okay, I square is equal to minus 1. We all know I raised to 4 is plus 1. So this minus 1 can be absorbed by writing here is I square. So I square x square by 2 factorial. Again, minus 1 sign is here. So I can replace it by another I square, and one I is already there. So it will be like I cube x cubed by 3 factorial plus I raised to 4 into x raised to 4 by 4 factorial. Since I raised to 4 is equal to plus 1, so this term is as good as writing x raised to 4 by 4 factorial, right? And just go on. This is again I raised to 5 into x raised to 5 by 5 factorial. So since I raised to 4 is plus 1, so these two terms are equal. Okay, I have just done a little bit modification, right? Let's see what is this, do some manipulation again. I'll put the brackets around. So this sum is equal to 1 plus ix whole square by 2 factorial, ix whole cube by 3 factorial, ix whole raised to 4 by 4 factorial and so on. What is this? If if you see this, it is like 1 plus x squared by 2 factorial, x cubed by 3 factorial, x raised to 4 by 4 factorial. What is this? This is an exponential function, right? Only thing is x is replaced by I time x here, right? So if you want to see in detail, let's go ahead, right? So e to the power x is what? 1 plus x squared by 2 factorial plus x cubed by 3 factorial. On the same line, I can say e raised to ix is equal to what? This is my LHS, right? 1 plus ix squared by 2 factorial, ix cubed by 3 factorial, and so on. So equation number 2 and equation number 1 are same. So LHS is equal to RHS. And hence the proof for Euler's identity. Cos theta plus I times sin theta equal to e raised to I theta. It's proved. So if you got any doubts, you can write below in comment section. Any suggestion, if you have any new ideas, you can suggest me. And please don't forget to like and subscribe my channel. I'll be coming up with few more tricks. Thank you.